ओके, बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम स्टूडेंट्स। आज के इस तीसरे सेशन में डिज़ाइन से लिंक है। वी हैव रीच द इनकोडर टॉपिक, और अच्छी बात यह है कि इनकोडर की एक एग्जांपल हम ऑलरेडी कर चुके हैं। सर्किट जो है ये डिकोडर सर्किट का रिवर्स होता है, और इसमें अगर हम ट्रुथ टेबल एक देखें, 8 into 2, sorry, 8 into 3 primary decoder, because it is 2 to power n into n. Okay, so n is 3, so it will become 8 into 3. So 8 into 3 encoder. So we have 8 inputs: D0, 1, 2, 3, 4, 5, 6, and 7. And for each input, there is a condition which will generate one output, and output is 0, 0, 1 for this case. So that means we have minterm 0. If I write M here for minterm, so minterm 0, 1, 2, 3, 4, 5, 6, and 7. So this is the case. So we can design, but the problem is here that we do not have a method, a map method for feasible for 8 variables. हमने जो पढ़ा है वो अभी तक जो मैप पढ़ा है वो पढ़ा है जी अप टू 4 वेरिएबल्स, ठीक है। बट फॉर्चुनेटली वी हैव अनदर simplification here, and that simplification is very surprising, that we can generate x by using only those inputs for which x is 1. So remember, x is 1 for these 4 cases. Okay, so we go and see, okay, d4 is present, d5 is present, and d6 is present, and d7 is present for these 4 inputs. So we can write x as a 4 input OR gate, so that it can detect if any of the or more of the inputs are 1, then it can generate a 1. But in this case, because we restrict ourselves to only allowing one input to be high, और इस कॉन्फ़िगरेशन का एक स्पेसिफिक नाम होता है जिसको वन हॉट कॉन्फ़िगरेशन कहते हैं. So we only allow one input or one output to be one at any point in time. तो हमने यहाँ लिमिट लगाई हुई है, वरना 2 की पावर 8 means 64 inputs can be arranged on the left side of this truth table, which we have limited to only 8 because of the output. क्योंकि आउटपुट में हमारे पास 8 ही कॉम्बिनेशन बन सकते हैं. So in this case, x will be equal to a sum of d4 and d5 and d6 and d7. So remember, this sum is primarily a logical addition. So any of the input 1 will generate the x automatically. So this is the primarily the main theme behind this encoder, and there is nothing special. It is a simple standard IC which is available, और आपका जो सिमुलेटर है, जो इलेक्ट्रॉनिक वर्कबेंच है, you can find there as well. So if we can go for y, for example, so we have the following equations. So as you can see, x is d4, d5, d6 and d7, जो अभी हम देख रहे थे. Then y is d2, d3, d6 and d7, and z is d1, d3, d5 and d7. So a very small and very easy circuits. Only we need 4 input OR gates and 3 of those to generate these outputs. So this is the encoder circuit. I am sure कि आप लोग इस चीज़ को समझ गए होंगे. Okay. There is an application of encoder circuit which is we are not primarily interested in, which is called a priority encoder, and it uses the don't care conditions, but we are not primarily interested in to learn those. We are interested in multiplexers. Because why we are interested in multiplexer? It's a very interesting thing that sometimes in initial development boards are primarily Arduino board and similar kind of primarily development kits which are available. So we have usually one input for serial in, जो बहुत स्मॉल बोर्ड्स होते हैं या जो कस्टम मेड बोर्ड्स होते हैं. So how we can interface a number of sensors to this a sensor array. So it is possible to use a multiplexer, and that multiplexer then have a number of inputs. Let's say 4 inputs. एक example के तौर पे, and we can have 2 select lines, and then these 2 select lines, then there will be one, they are attached to one switch, and then that switch is connected to the respective input. That. So we are controlling these lines from same circuit. So it is controlling. So control lines or select lines. So let's say these select line are S0 and S1. And this is our output. Let's say our output is F, for example. And we have the inputs W, We can write, for example, why write W? We can write, for example, input 1, I0, input I0, I1, I2, and I0. Okay. So now I can make a truth table over here. So whenever these inputs S1 and S0, these are the control lines, they can be 0, 0, 0, 1, 1, 0, and 1, 1. And we can have on our output, which is I0, I1, I2, or I3. Because we have a programmable control which can connect this point to any of the point uh, based on the binary value which is present on the controller. So by this way, we can attach 4 sensors to a single serial line to one controller. Okay, या one control element जो हमारे पास processing element है, जो हमारे पास बोर्ड है, फॉर एग्जांपल आमतौर पे हम इसको एक बोर्ड कहते हैं जिसके ऊपर हमारा प्रोसेसर लगा हुआ होता है, CPU, फॉर एग्जांपल कंप्यूटर कह सकते हैं. So this way, this is an application of multiplexer, and this is how the truth table actually generates it. A demultiplexer is opposite, and demultiplexer will actually connect one single line to multiple output lines. वो इसका उलट होता है. So now we see some examples from the book so that we can become familiar. Demultiplexer is not covered in the book, but the concept is the same. I would like to, let me first write the demultiplexer here. So demultiplexer is like this. So one line, and we have select lines, let's say S0 and S1. And this is our input I, and then we have multiple outputs, let's say F0, F1, F2, and F3. So depending upon the selection lines S1 and S0, we have the F0 output, F0, F1, F2, and F3. So the similar combinations 0, 0, 0, 1, 1, 0, and 1, 1. And we have the line number 1 will get I, others are 0. And similarly, on this case, I will appear on the input will appear on the first, and the rest is 0. And similarly, the next cases are the like this. So it looks like it is primarily a encoder or decoder type of things. So that thing, its application is more or similar like a encoder or decoder, जिसमें हमने sum की application पढ़ी थी. So we can implement an adder kind of thing here, or sum of product in a more general way. So these are the basic building blocks of the combinational logic circuits. And remember, the combinational logic circuits do not have a memory element inside, जो हमने उसको define किया था. So I just need to go to, okay, so this is the mux example of a mux, a multiplexer, and remember it's a 2 to 1, okay, 2 to 1, because it has 2 inputs and it has 1 output. So 2 to 1 mux, it only need 1 select lines. So the internal diagram is also shown here, how it primarily works, but the concept is very simple. If we have S is 0, then I0 will appear on here. So I0 will appear on here. And if S is 1, then I1 will on the output. Okay, so this way there is an internal switch which is primarily connected to the lines depending upon the value of this. So this is primarily the 4 to 1 line multiplexer, and as you can see it has 2 select lines and 4 output lines, 4 input lines and 1 output. One output is connected to any one of them. So Boolean function can also be implemented by using the same setup, and we include an enable input as well. Okay, so depending upon if we can enable this module on our switch, our circuit board or not. So for example, this Boolean function, the example Boolean function can be implemented through the multiplexer in this way. This example is primarily shown how the primarily the Boolean function is implemented. So it is also an example in which sum of product can be implemented. Okay, finally we have a 3-state buffer, and a 3-state buffer is the final topic of this session. 20 से 25 मिनट मैंने कहा था, तो almost we are reaching the 20 minutes. So in a tri-state buffer, so tri-states, we are familiar with 2 states, logic 1 and logic 0, but there is also a thing which is called a tri-state buffer. The internal structure of a tri-state buffer, it is very simple, that we have inside the circuit we have a switch, and that switch is controlled through another input. Okay, so here it is shown that this is the C and this is the input E and this is the output 1. So because there is an internal circuit, and we remember that we have the power supply connected to this circuit. Remember the basic electrical engineering and the basic electronic concepts, that we have some positive voltage and some negative voltage is applied. So by using these power supplies, this voltage will remain on this output. So let's say we have 0 in, and we enable the control, and then we disable the control. Then this 0 input will come here and it will stay here. And when we want to make it 1, we make it the input 1, and then we enable the control, and we send a very short on the control, so that the output become change. So the output will become from 0 to 1, and then control come back. जो switch है उसको off कर देगा, and we have the high level which is stayed on the output. So this kind of setup leads us to a 3-state buffer, और इसमें हम इसको कहते हैं high impedance state. Why high impedance? We know that a resistance, when it goes to value infinity, it becomes an open circuit. Okay, we can assume it's an open circuit. So this open circuit is made through this control, and then the use of the power supply with the buffer circuit, the output will hold. So this is the basis of the memory elements, जिसमें हम जो है वो sequential logic जो है वो पढ़ेंगे. जी, any question here? जी students, we are almost in today's session. If you have any question, you may ask now. जी बेटा आप लोग सवाल पूछ सकते हैं। फैसल आपका बेटा कोई सवाल है?
नो सर।
थैंक यू वेरी मच। मिस हिना आपका कोई सवाल है? जी दिलावर आप कुछ कहना चाह रहे हैं बेटा?
नो सर।
जी मुस्तफ़ा आप बताइए।
नहीं सर, कोई सवाल नहीं।
ओके मिस सुमैया आप बताइए।
नो सर, क्लियर है।
ओके थैंक यू बेटा। अल्हम्दुलिल्लाह हम कम्बिनेशनल लॉजिक का सेक्शन भी कंप्लीट कर चुके हैं और मैं ये चाहूँगा कि आप लोग जो है वो इस वीक में जो असाइनमेंट और क्विज़ेस हैं उनको कंप्लीट कर लें। तो हमारी जो नेक्स्ट डीएलडी की क्लास है वो नहीं होगी इंशाल्लाह और आपसे अब नेक्स्ट वीक में मुलाकात होगी। और मैं ये चाहूँगा कि आप जो है वो जो असाइनमेंट्स और क्विज़ेस हैं उनको आप कंप्लीट कर लें, ठीक है? ताकि मैं आई विल ऐड अनदर असाइनमेंट एंड अनदर क्विज, ताकि आपके 3 क्विज और 3 असाइनमेंट्स जो हैं वो कंप्लीट हो जाए। देन वी विल हैव एन एडिशनल क्विज एंड एन असाइनमेंट इफ इट इज रिक्वायर्ड। ओके ठीक है बेटा? तो फिर इंशाल्लाह नेक्स्ट वीक में मुलाकात होती है। इफ़ यू हैव एनी क्वेश्चन आप व्हाट्सएप पे ग्रुप में पोस्ट कर दीजिए, हम इंशाल्लाह मिलके उसको आंसर देंगे। अल्लाह हाफिज़, अपना ख्याल रखिए।